Welcome to Sundar's lecture. This is lecture number 49, and in this lecture we are going to see network theorems. There are so many network theorems available. So what is the purpose of network theorems? Network theorems are a specific procedures to solve the electrical network, and it will be helpful to find what is the current through a particular resistor. There are so many network theorems are available, maybe Thevenin's theorem, Norton's theorem, maximum power transfer theorem, superposition theorem, substitution theorem, reciprocity theorem, uh, and then Millman's theorem. There are so many different theorems are available, and I am not going to reveal all those theorems now. Before that, we try to get better knowledge about what is superposition theorem. See, this is the given circuit, and I am not going to tell you what is superposition theorem exactly or the definition before solving a problem. Try to understand. We will solve this problem and get the knowledge about superposition theorem. Then we try to write the definition by ourselves, maybe in our own words. Right? So this is the superposition theorem. In everywhere you go, if you are going for the network theorems, obviously they will give you the load resistance. This is the particular load resistance, and you need to find the current through that load resistance. Right? So this is the given circuit. I have taken a simple circuit. Maybe to understand things, I have taken a simple circuit. So this is the circuit. We have 20 volt source, 4 ohms, and so many things. And we need to find what is the current in this load resistance. This is the load resistance they have given. 3 ohms resistance will be the load resistance. And current, we need to find what is the current in this resistance. That is displayed as IL. See, this current direction is very important. Very important. You need to find what is the current through this 3 ohms resistor in this direction. If they have given you in opposite direction, then you need to consider that as the current direction. Try to understand. Because why I am telling this one, so many students will make a mistake in current directions while solving the problem by superposition theorem. See, they will give you, obviously they will give you the current direction, or if they are not giving you the current direction, you assume any one direction. Right? So this is the direction. So first of all, I will write the formula to find what is the current in this 3 ohms resistor. Right? So maybe I will write it as IL will be is equal to, I will write it down, then I will tell you, I by 20 volt plus I by 1 volt plus I by 2 ampere source. See, if you want to find what is the current in this 3 ohms resistor, what you do, you just activate this 20 volt source and then you deactivate this 1 volt source and 2 ampere source. Create a circuit and you find what is the current in 3 ohms resistance in this direction. That is nothing but I by 20 volt. Then what you do, for the second instant, you just activate this 1 volt source and deactivate 20 amperes and 2 ampere source. Then find what is the current through this 3 ohms resistor in this direction. Maybe it may be positive or negative. And that is the I by 1 volt. Then if you want to find what is I by 2 amperes, you activate this 2 ampere source and deactivate this 1 volt and 20 volt. Find current through this 3 ohms resistor in this direction and sum up all the values. You will get what is the current in this 3 ohms resistance. This is the procedure. So for that, first I will take 20 volt. I just try to activate this 20 volt and deactivate this 1 volt and 2 ampere source. Deactivating means if it is a voltage source, you need to short circuit, and if it is the current source, you need to open circuit, and you have to replace it by internal resistance. There is no internal resistance given here, so it is not a big thing to replace these two sources. If it is a voltage source, then no short circuit. If it is a current source, then open circuit. So I'm just going to activate the 20 volt source and I'm going to deactivate 1 volt and 2 ampere source. See, I have drawn the diagram. Activate 20 volt source. I have only activated the 20 volt source and I have deactivated 1 volt and 2 amperes sources. Now what you do, you need to find what is the current through this 3 ohms resistor, and I have written it as I by 20 volt. And it is very simple, right? So if you want to find I by 20 volt, then what is the formula? It is simple. So this is the single loop problem. So I by 20 volt will be is equal to 20 by 7. That's all. 20 volt by the total resistance, it will be 7. So if I simplify this one, I will get, so it will be 2.86. See, current, what is the current in this loop? So it is very important to know the current. Only single loop and the current should follow from minus 2 plus in the source, because there is single source is present in this particular problem, maybe particular circuit, right? So the current that should flow in this direction, and we are going to find the current in 3 ohms resistance, and that is also in this direction from top to bottom. That is very important, right? That is what they have given you here also. So it will be I by 20 volt will be is equal to 2.86 amperes. And what I need to do, I will activate this 1 volt source and I am going to deactivate 20 volt and 2 ampere source. See, I have activated 1 volt source. Only 1 volt source is present here, and the 20 volt source has been deactivated by short circuiting, and this 2 ampere source has been deactivated by open circuiting. So now you see, this is I by 1 volt and I need to find what is the current in this direction. But if you want to solve this problem, then your natural current will flow in this direction. Try to understand, in this direction, because your source 1 volt is here. So your current direction will be opposite. It should be in this way, right? That is this one. Maybe this is I in this particular loop or particular mesh. So now, but you need to find a current in this direction. See, if you are getting this current, it will flow in this direction. But I need to find what is the current in this direction in 3 ohms resistance. Since my question, in my question, I need to get what is the current in 3 ohms resistor in top to bottom direction. But if you are taking this circuit, your natural current will flow in the opposite direction. So what you do, you just find the current and put a negative symbol, since the current direction I need to find from the top to bottom. That is very important. So many students will do a mistake here. They will put a answer in positive values, but it is a different one. So if you want to find what is the current through I by 1 volt source, I by 1 volt source will be is equal to, see, there is only 2 resistance 7 ohms or single loop, so it will be 1 by 7, and that should be is equal to, see, I am going for the total current, the I by 1 volt, but the total current would have been in a negative way. So I have to put it in a negative direction. It is negative, right? So if I simplify this, so it will be minus 0.143, minus 0.143 amperes. So that is the difference you need to get here. So I by 1 volt will be this value. I by 1 volt will be is equal to minus 0.143 amperes. See, your natural current will be in this direction. You try to understand. That is why I am repeatedly telling this one. Why I am putting negative symbol? I need to get the current in this direction, but your natural current will follow in the opposite direction. That is why I have taken the minus here. So what is the next thing? I need to activate 2 ampere source. So now you see, I have taken 2 ampere source and I have deactivated 1 volt and 20 volt source. And I need to find what is the current in this direction in 3 ohms resistance. See, here your current is flowing in this way. So it will be 20 amperes. This will be 20 amperes, right? So obviously the natural current will flow in this direction, So whatever the answer you are getting here, that will be a positive answer, right? So if I simplify this one, maybe you can apply current division rule, because these two resistors are connected in parallel. So if I want to find what is I by 2 amperes, that should be is equal to 20, total current is 20 into what is the opposite resistor here, that is 4 ohms resistor, that I need to put here, 4 ohms by what is the total resistance, that is 7. So that is 7. So I by 2 amperes will be is equal to, sorry, maybe I have made a mistake, it is not 20, it is 2 amperes, right? It is 2 amperes, 2 amperes, 2 into 2, it is not 20, again here I have made a mistake, it is not 2 amperes, it is not 20 amperes, it is 2 amperes, right? 2 amperes. So I have made a mistake. So 2 amperes. If I simplify this, I will get 1.143, 1.143 amperes. Right? So we have found all the values. I by 20 volt, I by 1 volt, I by 2 amperes. Now you need to consolidate every answers. So if I consolidate everything, so IL will be is equal to, so 2.86 amperes, 2.86 plus maybe minus, right, minus, because this is minus value. So this will be minus 0.143 and plus it is 1.143, and I will get finally IL will be is equal to 3.86 amperes. 3.86 amperes. So that is the IL value. Right? So now what we will do? We will write the definition now, because we know what is the superposition theorem really means to us, right? So definition will be, current through a resistor in a circuit is equal to the sum of the current delivered by individual source. Individual source, maybe we will write it as individual source in the resistor, so that you can easily understand this, in the resistor. So this is the definition of superposition theorem. Maybe we will take the circuit and we try to solve this by mesh current analysis method to find what is the current in this 3 ohms resistor, so that we can easily compare these two results and we get a good idea about superposition theorem. So we will take this circuit to the next page and we will find it by mesh current analysis method. So I have taken this circuit. Now we are going to solve this by mesh current analysis method. So how will we find it by mesh current analysis method? So we need to draw the current directions, and so I am just taking this as I1. See, I2 is already given, right? Because this is 2 amperes. We have seen these kind of things already. Anyhow, I will go for it again. So we need to find, or maybe I2 is given. I2 is equal to 2 amperes, that is given. And what is the current direction in the 4 ohms resistor? It will be like this. It is I1. And what is the current direction in 3 ohms resistor? This is I1. That is this current I1. But I2 also in the same direction. So it will be I2. It will be I2. So now if I want to solve this problem, I need to go for the first loop. I am just going to write the first loop expression. If I am writing the first loop expression, it will be 20. I am going in the same direction, so it will be minus 4I1 from plus to minus. In the 1 volt source, it will be minus I1, minus 1 volt, and then I am going in the same direction, so it will be minus 3 into I1, and again the current direction is same as I2, so it will be minus 3 into I2, which is equal to 0. So if I further simplify this one, what I will get, so there are 2 I1, so it will be minus 7 I1 minus 3 I2. What is I2? We know that this is 2 amperes. it is given. So it will be 2 and then 20 minus 1. So it this 3 ohms is written, this 3 into I2 is written. So 2 minus 1, it will be plus 19, which is equal to 0. So now if I further simplify this one, so I bring this 7 to that side, 7I1 to that side. So it will be 7I1 and 19 minus 6 will give you what? 13. So I1 will be is equal to 13 by 7. And if I simplify this, so I1 will be is equal to, so 1.86 amperes. That's all, right? I1. And we know what is I2. It is very simple, right? You need to put a mark here at this point, and that is node A. So apply KCL at node A. If you are applying KCL, what is this one? This is I1, and this is what? This is nothing but it is I2, and we need to find what is the current in this direction, that is in 3 ohms resistor. So this I am taking it as I by 3 ohms. So what you will get, I1 is coming in, I2 is coming in, I3 is going away. So I1 plus I2 will be is equal to I through 3 ohms resistor. So if I simplify this one, I through 3 ohms resistor will be is equal to, what is I1 I have got? It is 1.86. It is 1.86 plus what is I3, sorry, what is I2? I know this is 2 amperes. This is 2 amperes. So if I simplify this, I through 3 ohms will be is equal to 3.86 amperes. Right? Now you see here, see we have got 3.86 by solving the same problem by superposition theorem. So whatever the answer we've got, it is correct. Right? Maybe you will ask that why I need to find in this way, because it is very simple. It is very simple here. We have followed a different procedure. Maybe the superposition theorem will put a good platform for so many theorems. Maybe we are going to see Norton's theorems and Thevenin's theorems. We are going for those theorems. This superposition theorem plays a major role. So you go through this superposition theorem procedure, and we will take a new topic, maybe new theorem in the next class, that is substitution theorem. And both superposition theorem and substitution theorem put a good platform to understand other theorems, maybe Thevenin's, Norton's theorems. Thank you. We will see in the next class.